Okay, now folks, some practice questions to make sure we know what we're doing with these equalities and sort of supplementary properties of parallel line transversals. So we're going to talk about defining, we already did all this, defining transversal, parallel line transversals and their angles, and properties of parallel line transversals, but just some practice questions now. Okay, first one says, what is the measure of angle alpha? That's what that little Greek letter is, alpha, in the diagram shown. Okay, so this is kind of a funny question, and I like funny questions, but I like this one in particular because we really have two transversals here. This creates a parallelogram when I have two parallel lines transversing two other parallel lines. Okay, so there's lots of different ways I can figure out what angle alpha is, but let's start with the one bit of information that we have, which is 130 degrees. Okay, so for that 130 degrees, I want to be able to work my way all the way over here to get alpha. So the first thing I'm going to do is try and think of ways that I can get close to alpha. Well, I can figure out some angles maybe inside that parallelogram. The first one I want to go after is this one up here. So if I think about these two lines as being parallel, and I think of this one as being a transversal, then 130 degrees and this missing angle that I've also labeled up here are going to be what we call corresponding angles. And we know that corresponding angles are congruent, so this has to be 130 degrees as well. All right, so now what I want to do is I want to sort of switch my mind around a little bit, and I want to think of these two lines as being my parallel lines, and I want to think of this one as being my transversal. Okay, and if that's the case, then alpha and 130 degrees are inside the parallel lines, so they're interior angles, and they're on the same side of that transversal, so they're same side interior. Okay, and we know that same side interior, that's the one group we had that's supplementary, so they have to add up to 180 degrees. So that means that 130 plus alpha has to give us 180. Whoops. So that means alpha is just 180 minus 130, which is 50 degrees. Okay, good question. Next one, determine all unknown angles in the diagram. Okay, so what we have here, it looks like two transversals cutting across a couple of parallel lines, and we sort of have to fill in any angles we can find. Okay, so let's start down at the bottom here. If we have a 60-degree angle, then we know that across 180 degrees for a straight line, we'd have to have 120 to make up the rest of it. 120 and 60 is 180. And then I guess this angle would have to be 60 because it's vertically opposite the 60. And this angle would have to be 120 because it's vertically opposite the 120. Okay, then we can fill in everything at this transversal where it hits this line up here, because now we have the four corresponding angles. So corresponding here, we'd have to have 120. Corresponding here would be a 60. Corresponding here would be a 120 and another 60. Okay, so we've got all those, and I think that's as far as we can get since there's nothing parallel to give us anything up at that one. So let's try the other transversal now. So by the same token, we know that this is 180 degrees here, so that would have to make this 140. So we'd add up to 180 degrees. So then using vertically opposite angles, we have 140 there and 40 degrees there. And then we just fill in the corresponding angles up here. We'd have to have a 40 and a 140, and then another 40 and another 140. Okay, so now how are we going to be able to get the angles that are around this point? Well, you'll notice that what we have in here is a triangle. And the angles in a triangle have to add up to 180 as well, don't they? So we already have 60 plus 40, and then plus whatever angle this is going to be up at the top has to equal 180 degrees. Okay, so that question mark is going to be 180 minus 60 plus 40, which is 100. So we're going to have 80 degrees up there. So this one is 80 degrees. So its vertically opposite counterpart here would have to be 80. And then again, we can just use our properties of 180 degrees here, making this 100, and it'll also make this one 100 degrees over here. Okay? And that's how we find all those angles. Boy, that was fun. Okay, so same stuff, just the same things we highlighted it last time, all the right pairs and what they do with each other. Great.